Hi, I'm Ray, and today I'm going to start with Pre-Calculus Lesson 1. And this is provided by A1Prep, so I'm just going to get started. So the textbook I'll be using in this course is Pre-Calculus Enhanced with Graphing Utilities, written by Sullivan. I'll be basing my lessons on the 6th edition, but other editions may well accompany this course as well, or you can go ahead and get a copy and read it yourself and go along with these lessons, or just simply enjoy the lessons itself. So let me just start off today's first part, distance formula. So distance formula, definition is the distance between 2 points P1 and P2 are denoted by D, and you write the points here P1 and P2, and this is the definition of distance between 2 points. Now let me show you this by example. Just look at this for now. Now remember that there's two coordinate systems. There's x1 and y1, x2 and y2. So there's 2 points, and we apply that inside this distance formula to find the distance between 2 points. So let me show you through an example how to do this. Okay. So find the distance between points 1, 3, and 5, 6. So let me start off with drawing coordinates. So 1, 3 here, and 5, 6 would be somewhere around here, okay? So let me write out the coordinates for you guys. So distance, right? Distance is simply the shortest length you draw, usually a straight line. So the distance formula states that we have to find the square root between the difference of 2 points squared. So let me show you writing the distance formula. So, in this case, x2 and y2 is simply the second point we're applying. So 5 and 6. So let me just write that out. 5 and 6. Next, the x1 and y1 is indicating 1 and 3. So follow that. Let's put that in there. So let's see what we get. That comes out to be 4 squared plus 3 squared, so that comes out square root of 25, which is distance is 5. So now let me tell you something about the distance formula, where it comes from. Okay, the distance formula, where it derives is from actually the Pythagoras theorem. So if you draw a triangle in the coordinate system, you can see that this distance length, we call D, is in fact the sum of square, which is square rooted between the x length and the y length. So if you see that, you can realize the distance function is actually an extension of the Pythagoras theorem. Hopefully you guys have learned this in geometry. And in fact that, because we know that the triangle, so let me show you the triangle equation. A right triangle always has a length of x squared plus y squared equals d squared in this case. We know that the distance between 2 points can be derived from using the coordinates of x and y's in this case. So, move on. Now the second I'm going to teach you guys today is the midpoint formula. So the midpoint, defined as the midpoint, literally means the middle point of a line segment from P1 to P2, any points, and it's given by x1 plus x2 over 2, then comma y1 plus y2 over 2. So again, just take a look at this quickly. I'll show you how to use this and apply this in the next example. Okay? So midpoint again is the middle point of a segment. So let me show you what that means. Okay? So in this example it says find the midpoint and between the points 1, 3 and 5, 6. Again, let me draw the coordinates out. 1, 3 should be around here. 5, 6 should be around over here. Again, we can draw a straight line, which shows the distance, and the midpoint should be around here in terms of this graph. So let me use the equation first. So the midpoint coordinate will be x1 plus x2, which is again, this is x, that's x. So 1 plus 5 over 2, 3 plus 6 over 2 for the y's. Then you end up with a midpoint of 3 and 4.5. So, where does this come from? Again, let's take a look by drawing a triangle. So, this coordinate, we can actually split this line into terms of the x part and y part again. So, in this case, we're looking at the average distance of the horizontal and the average distance of the vertical distance. And that's where the equation of over half comes from. So if you can remember this, guys, that in the midpoint in a segment, you always remember that it's the average distance between the x coordinates and the y coordinates. So that's how you find the midpoint. So let me move on. Okay, so let me move on to intercepts. Now intercepts, let me start by defining it. The points, if any, at which a graph crosses or touches the coordinate axis are called intercepts. So let me show you on the graph what intercepts are. Okay? So on this plane, I have a straight linear graph. So the x-intercept would be where it touches the x-axis, which is this point, and the y-axis would be the point where it touches the y-axis. Okay, so finding x-intercept and y-intercepts. For finding x-intercept, which is this point, we would let y equal 0. Now the reason behind that is, at this point, if you look carefully, it will always have a y value equivalent to 0. Now moving on to the y-intercept, at this point, we'll always have an x value equal to 0, regardless of whatever y value we contain. So that's how you find the intercepts. Okay? Let me show you again in the next example how to do this. In just in a second, let me just talk about symmetry. Now, symmetry means that, hopefully you guys know the literal meaning of symmetry, is that it reflects or that it copies itself. Now, when we say symmetric with respect to the x-axis, it means that for every point x, y, point x, negative y exists. So let me show you that on the graph again. So first, we start off with symmetric with respect to the x-axis. Okay, so this is x-axis. Remember that? So I'll have a graph something like, let's see, that. Now, if you look carefully, what's going on is that if we look at the x-axis as if it's a mirror, the graph is completely reflected. Now, you realize, let's just pick some points, okay? So let's pick a point here and call this negative 1, 1. And now since it's symmetrical, this point should be negative 1 and negative 1. Now, if you look carefully, the x value stays the same, while the y value actually inverts in its positive and negative sign. And that is why we call symmetric with respect to the x-axis that xy changes into x negative y. Now moving on to the symmetric with respect to the y-axis. So in this case, I'm going to show you guys the y-axis reflection. Leave that point. Okay, so again, we reflected this graph on the y-axis, which made it symmetrical. So again, we can put a coordinate here, and if we look at the point, we realize that it's 1, 1. Now again, this time, if it's reflected on the y-axis, the y-coordinate stays the same, while the x-coordinates change their sign of positive and negative. So remember that, guys. So when it's reflected with respect to the x-axis, the y-axis changes sign, while if we reflect it on the y-axis, the x-axis actually changes its sign. So lastly, let me go on with the symmetricality with the origin. So the easiest graph that we can do is actually y equals x. Okay? So y equals x is a graph that is symmetric with respect to the origin. Now the origin is where? Here, 0, 0. So now we're looking at 0, 0 as a point of where we're reflecting. So in this case, since this point is 1, 1, now we can have a point here that's called negative 1, negative 1. Now, again, reflecting it on the origin, we change both signs on the x and y in terms of positive and negative. So if you remember that the x and y changes signs depending on its symmetricality. So soon, I'll cover this in the next example as well, so just wait a bit if you're having a hard time catching up to this. So let me go through the example quick. So let me go through the intercepts and symmetry in this example. So for the equation y equals x squared minus 4 over x squared plus 1, find the intercepts and test for symmetry. So first, let's find the intercepts. So we have the equation y equals x squared minus 4 over x squared plus 1. So what do we do when we find the intercepts? First, let's find the y-intercept. We do what? We let x equal 0. So let's do that. We let x equal 0, then y equals negative 4 over 1. Therefore, the y-intercept is negative 4. Now the x-intercept, oh, sorry about that. X-intercept, okay, intercept. We let y equals 0. So in this case, we let 0 equals x squared minus 4 over x squared plus 1. We can multiply x squared plus 1 on both sides to get rid of it. So we cross multiply. So we end up with 4 equals x squared. So the values that satisfy x squared equals 4 of x are x equals plus minus 2. So these are the x-intercept, and this is the y-intercept. Okay, so the y-intercept is negative 4, and the x-intercept is plus minus 2. Why? Because if you let the values of x and y respectively go to 0, we get these values. So now let me go to the second part of the question, testing for symmetry. Now testing for symmetry, what's important to remember is that the three different types of symmetry, again, if xy, for every xy there exists x negative y, this is symmetrical to the x-axis. For every xy, if there exists negative x and y, this is symmetrical to the y-axis. And lastly, for every x and y, if there exists negative x and negative y, it's symmetric to the origin. Okay? Now the way to test these are that you input x and compare it with inputting negative x, or vice versa, you input y and see the results compared to negative y. So in this case, let's start off with x and y. So that would simply be the exact equation. Inputting x would be y equals x squared minus 4 over x squared plus 1. Now inputting just negative x, we would get y equals x squared minus 4 over negative x squared plus 1, which is equivalent to x squared minus 4 over x squared plus 1. So in fact, inputting x and negative x ended up with the same value of y, which means that this graph is symmetric about the y-axis. Now, to look for symmetric with respect to the x-axis or the origin, it's the same thing. So if we input x, we don't get a different y value. So we immediately know that, in this case, it's not symmetric to the x-axis. For the origin, we ended up with y, not negative y, so we know that it's not symmetric about the origin. So our final answer for testing for symmetry is that this graph is symmetrical to the y-axis. Okay, so that's it for intercepts and symmetry. Now, let's move on. Next, slope. Now, let me start off with the definition of a slope. The slope, m, usually defined by m, of a line L is defined by m equals the second y-coordinate minus the first y-coordinate over the second x-coordinate minus the first x-coordinate. Okay, so a slope of a line can be also determined as rise over run. It simply means that we're looking at how slanted or how the graph is oriented in terms of the rate of change that it goes through in this graph. So in this case, we can also write slope m as change in rise over change in run, which is exact same thing as change in y's and change in x's. Okay. Also, important thing about slope is also known as the average rate of change. Remember that. That slope is equivalent to average rate of change. Okay. So, let me go through different cases of slopes. Okay. So let me leave that. So, let's start off with the vertical line, some special cases, which is the vertical line. So vertical line means straight line like that. So in this case, what is the rise over run? So clearly, the rise of let's just pick 2 points. Let's call this point 1, let's say 1 and 1, and that point has 1 and 3. Since it's a vertical line, remember, a vertical line shares the same x coordinates. So this is important. A vertical line shares the same x coordinates. So in this case, let's try to define the slope. So the change in rise in this case would be 2 over the run. In this case would be 0. So now, important mathematical concept is that when you have the 0 as the denominator, this is always undefined. So, what I'm trying to tell you guys is that the slope of a vertical line will always be undefined. Why? Because the run is always 0, and in terms of a fraction, you cannot have 0 as a denominator, it will be undefined. So, a slope of a vertical line is undefined. Now, let's move on to a horizontal line. So, a horizontal line would be like that. Let's pick a few points. Call that 1, 1 again. Negative 1, 1. Okay, so in this case we have a horizontal line, a line that goes straight through this coordinate plane. Important thing again is that it shares the same y-axis. Anywhere you pick a point on the line. So again, let's see what the rise is. Rise is 1 minus 1, so it's 0 over the run. In this case will be 1 minus minus 1, which would be 2. But slope is 0. Why? Because it never rises. It never changes in the y-axis. So we know that a horizontal line will always have a slope of 0. Okay? So remember that. A vertical line has an undefined slope. A horizontal line is 0. So let's move on. Next, I'm just going to talk about a few forms of graphs. Now the first I'd like to introduce to you guys is the point slope form. Now we just learned about slope, right? The average rate of change. Now we can apply that in terms of a graph of a linear form. If it has a slope m and contains a point x1, y1, we can write it as y minus y1 equals m and brackets x minus x1. Okay, so what do I mean by this? So if I have a graph, let's just say I have a graph like that. This point is 2, 3, and it has a slope of half. Then we can write this line equation as y minus, this is the x1, and that's the y1. We can write this as y minus 3 equals half multiplied by x minus 2. So this is the point slope form. Why? Because we can look at the points immediately. By looking at the x and y here, we can tell that it will contain the point 2 and 3, and it will have a slope of 1/2. Also helps us in graphing if we ever see this equation in real life. So now, let me talk about the vertical line and horizontal line. Again, special cases. So in terms of a vertical line, let's keep the point 2, 3. Draw a vertical line. It's terrible. Draw again. So So in this case, now what do we say about the slope of a vertical line? It's undefined. So in this case, we can actually not represent this as slope, point slope form. Why? Simply because the slope is undefined. So let me look at different ways of defining this. So in terms of this graph, if you can't describe the slope, let's just try to describe it as in terms of just an equation. So what do we know about the vertical line is that it shares the same x-axis, correct? So the x-axis is always on 2, so we can actually write this equation as simply x equals 2. Okay, so that's how you represent vertical lines. Okay? If the line was here and the x over here was -1, then this would be x equals -1. Okay, now let's talk about the horizontal line. So the horizontal line has a slope of what? Has a slope of 0. So I'm going to draw a horizontal line with slope 0 and call this y-axis 0.3. Okay, so if the y-coordinate is 3, we can write this as y equals 3. Okay? Okay. So, line here has a slope of 0, so we can see that it correlates with this equation. So if you actually write this as point slope form, we would end up with, regardless of this, see how this becomes 0, so we end up with y equals 3 for the horizontal line. Okay, so let me move on. Okay, next form is the slope-intercept form, okay? Another common form of linear equations, when you have slope m and y-intercept b, we can write the equation as y equals mx plus b. Okay, so if I had a graph, okay, so let's say, remember it's the y-intercept, so it meets here. Say this point is 0, 2. Again, y-intercepts have value of x equals 0, 0, 2. And let's just say the slope is 1. Okay. So in this case, we could write this equation as y equals x plus 2. Okay. So the advantage of using this type of form is that we can immediately see where the y-intercept is, and the slope is simply the constant here in front of x. Remember that. The constant in front of x is always the slope, and the constant that goes on with this equation at the end is the y-intercept. Okay? In terms of a vertical and horizontal line, again, the vertical line has a slope of undefined, so we only need to define x-axis. So if I had a line that goes straight through here, and call this point 4, again, a vertical line would be defined as x equals 4. A horizontal line that may go through here, that may, let's say this is 5, would just be simplified as y equals 5. Okay? Notice that the slope here is 0 and the slope here is undefined. Okay? Remember that not every equation may have a slope that may apply to this form. But just remember, guys, that this is the slope and that's the y-intercept. Okay? So next form is the general form. So the general form is ax plus by equals c. Okay, so in this case, let's just say we have a equals 1, b equals 1, c equals 5. Okay, so let's just write that out. X plus y equals 5. Okay, this is equivalent to y equals 5 minus x if you write this as slope-intercept form. Now, often you won't see this general form as much, but it's always good to remember that there's different forms of linear equations, and it's good to know every form if you can, and apply them if needed. So, in case of a vertical and horizontal line, again, same thing. A vertical line will always share the same x-axis, so you end up with x equals a constant. For the horizontal line, you end up with y equals a constant, c. Okay? So let me move on and talk about parallel lines. Okay? Now parallel lines are two non-vertical lines if and only if their slopes are equal and they have different y-intercepts. Now important thing is different y-intercepts. Okay? Example. So find the equation of a line with slope 3 containing the point 2, 3. Okay? So first of all, what are parallel lines? Okay, on the coordinate plane. So if I have a line like this, it means lines that are here or maybe here. Notice that they all have the same slope and that in fact they do not meet each other. That they will never coincide even if they infinitely move on. Now that's the important definition of parallel. Now hopefully you guys learned this in geometry that they never meet or touch. Now why is it important that they have different y-intercepts? If they had the same y-intercept, let's just say this had a y-intercept of 2, and this had a y-intercept of -1. If the y-intercept were equal, this line would actually coincide with the same line, second line here, we would not make it parallel at all. So important thing to remember is not only parallel lines have different slope, same slope, but they have different y-intercepts. Okay? Same slopes, different intercepts. Okay? So let me go through the example with you guys. So it says, find the equation of a line with slope 3 containing a point 2, 3. So if I want to find the equation of a line with slope 3 containing a point 2, 3, so let me just start off with 2, 3 around here. Okay? If it has slope 3, then it should be something like that. Okay? So how do you find the equation? Simple, we use the point-slope equation. You just learned that, right? The point-slope was y minus y1 equals m bracket x minus x1. So, applying this, same thing. Y minus, the y coordinate is 3, equals slope 3, x minus 2. So, you can actually simplify this if you want to. So, that would be y minus 3 equals 3x minus 6, y equals 3x, add 3 on both sides, that would be minus 3. So this is the equation of a line with slope 3 containing the point 2, 3. Okay? Next, perpendicular lines. Okay. So, perpendicular lines, okay? Perpendicular lines are perpendicular if and only if the product of their slopes is -1. So what do I mean by that? So if I have a coordinate plane here, I have a line here, and if I have a line perpendicular, now remember perpendicular means 90 degrees. If it's perpendicular, the slope here, I'm going to call this M1, and the slope of the second line called M2, they're a product of their slope, so M1 multiplied by M2 is equal to -1. So that defines perpendicularness of two lines. Okay? Now, if you guys want a proof, you can look it up online. I'm not going to go over the proof. However, in any case, perpendicular lines will always have product equal to -1. Okay? Often, we might say that the slope of the second line is a negative reciprocal of the first line. Okay? So let's go through an example. So finding the equation of a line perpendicular with the line y equals 2x plus 5 containing the point 2, 3. Okay? So let's start off with 2, 3. Again, around here. So if it's perpendicular with the line y equals 2x plus 5, it should be what? The equation of the line we're looking for should have a product of -1 with the line y equals 2x plus 5. So in this case, this line has a slope of, let's call this m1 equals 2. So, if m1 times m2 second slope equals -1, the line we're looking for should have a slope of negative 1 over 2, which is negative half. Okay, so now we know the slope is negative half. Again, we can use the point-slope equation to look for the equation of the line. We know 2, 3, so we can write y minus 3 equals, again, write the slope, negative half, x minus 2. Okay, to simplify this again, y minus 3 equals negative half x plus 1. We move on, we add 3 on both sides, so this is y equals negative half x plus 4. Okay. So remember that if a line is perpendicular to another line, the slope of the line we're looking for will always be a negative reciprocal to the original line we get. Okay, so remember that. Okay, let's move on. Okay, the last lesson of today is circles. Okay, a circle is a set of points in the xy plane that are fixed distance r from a fixed point hk. Okay, that's just constants. Don't worry about the h and k. It can be any point, any letter. Now the fixed distance r is called the radius, and the fixed point hk is called the center of the circle. Okay, so let me show you. Hopefully you guys all know what circles are. So if I have a point hk here, and if I draw a circle, the radius would be r. Okay? And this is what is called a circle. Same distance around one point. So how do we write this in terms of an equation? Now the circle form is written as x minus h squared plus y minus k squared is equal to r squared. So what does that mean? Okay? So first of all, a circle, important thing is that every point on the line here has to be equidistant to the point in the center. So again, we can draw a triangle. Okay? And call this point x, y. Okay? Now, we can apply what? The distance function we just learned today. How? The distance function is given by x2 minus x1 squared plus y2 minus y1 squared equals distance. Oh, sorry. Let's write the distance here. So distance formula was given by x2 minus x1 squared plus y2 minus y1 squared, square root of this. So the circle equation actually comes from this. If you look carefully, say this point is xy, so that would be the second coordinate, x and y, and hk would be the first coordinates of x1 and y1. So if we rewrite this, we can write this as d equals y, let me start off with x minus h squared plus y minus k squared. Okay? Now, what's important about a circle is that the points here, its distance, is always equal to what? R. So we can actually rewrite that d as r. Okay? Again, so if you square both sides, we end up with what? R squared equals x minus h squared plus y minus k squared. So the circle function, or circle equation, actually comes from the distance function. Because why? Because we know all these points have the same distance in terms of its distance from the origin. So applying the distance function and writing the distance as radius, we can actually write the circle equation as x minus h squared plus y minus k squared equals r squared. Okay? Now, let's say we have the center at the origin. Okay, so if we have the center at the origin, that would make h and k what? 0, 0. So this would be x squared plus y squared equals r squared. Okay? If the center is at the origin, the circle equation becomes x squared plus y squared equals r squared. Simple as that. Next, the unit circle. Okay? A unit circle is a special circle we define as unit because the radius is equivalent to 1. Again, let's just say the center is at the origin, so we would end up with, let me just write 0, 0 to indicate that the center is at the origin. That would end up with x squared plus y squared equals 1. And this would give us the unit circle around the origin. Okay? So, go through an example. Okay, so it says write the standard form of the equation of a circle with radius 5 at the center, -3 and 6. So you start off with the standard equation, x minus h squared plus y minus k squared is equal to r squared. Okay, so the center is at -3 and 6. So let's see, -3 we input in h, so that will make it x plus 3 squared. Okay, plus y minus 6 squared equals r, which is in this case 5. So it'll be 5 squared, or equivalent to 25. Okay, so writing the equation of a circle is simple if you know the radius and the center. Just need to write the center in terms of h and k, then you write the radius squared at the end. So that is what we do for circles. Okay, general form of circles. Again, just like linear equations, we have something called the general form of circles, which is simply just expanding every term on the left side. Okay, so let's just go through a short example. Find the general equation of a circle whose center is 1, -2, and whose graph contains the point 4, -2. Okay, so the center is at 1, -2. So what we start off with, or equation, x minus 1 squared plus y plus 2 squared is equal to, now in this case we're not giving the radius, let me just write r squared for now, okay? So that's what we started with, okay? So now the question is, how do you find the radius, okay? Now we're given a point that 4 and -2, and we're given a center. So what does that mean? In terms of a graph, I can show you guys. If I have a center at 1, -2, and the graph contains a point 4, -2, which is over here, okay, I'll have a circle. And what do we know? Distance between the center and the point on the graph would simply be radius. So in this case, what's the distance between 4, -2 and 1, -2? It's, in this case, since we have the same y-axis, okay, we can just look at the x-coordinates of 4 and 1. So the distance, or in this case, the radius of the circle, is 3. So we can actually write 3 over here. Okay? So, now writing this as general equation, we just write everything expanded, so that would be x squared minus 2x plus 1 plus y squared plus 4y plus 4. In this case, that would be equal to 9. And then we can just move the constants, so that would be 1 and 4, which is 5. Now, 9 on the right, so we move this on the other side, so we end up with x squared minus 2x plus y squared plus 4y minus 4 equals 0. And that is the general form of this equation of a circle. Okay? So remember, you start off with what you know, the standard form of the circle. If you're given the center, you can just input h and k value. Next, you can find the radius by looking at the center and the point on the circle. Okay, so we put that in, we move everything on the left side, and we can find the general form of an equation of a circle. Okay? So, get rid of this. Okay, so let me go through some review questions that we learned today. So, first one. Suppose the points -2, -3, and 4, 5 are on the endpoints of a segment. Find the distance between the 2 points. Find the midpoint of the line segment connecting the 2 points. Okay? Again, we start off with the distance function. Y, finding the distance. Again, x1. Okay, let me write that in. x1, y1, x2, y2. Okay, so the distance function is given by d equals x2 minus x1 squared plus y2 minus y1 squared. Okay, square rooted. So now we can just input the value. So that's 4 minus -2, which is 6 squared, plus that's 5 minus -3, which is 8, which is 8 squared, which gives us in fact 10. Okay? So that's the distance between these 2 points. Okay? Now, finding the midpoint of the segment. Okay? What do we do? Remember, midpoint means the average of the x-coordinates and the y-coordinates. So the midpoint is given by x1 plus x2 over 2, y1 plus y2 over 2. So inputting x1 and y2 again, x1 and x2, that's negative 2 plus 4, which is 2, which makes it 1. The y-coordinate is the average of negative 3 and 5, which is again 1. So the midpoint is given by 1, 1. Okay? Next question. Okay, next question. List the intercepts and test for symmetry of x squared plus y equals 9. Okay, intercepts. Okay, first, x-intercepts. What do? We let y equals 0. So in this case, that would make this x squared plus 0 equals 9. So the point where x squared equals 9 would be the x-intercepts, which would be x equals plus minus 3. Okay? Now the y-intercept. What do? We let x equal 0. So in this case, we let x equal 0, so that would be where the point y equals 9. So this is the y-intercept, where y equals 9. Okay? Now that we found the intercept, let's test for symmetry. Okay? Now again, testing for symmetry, we start off with x, y, and negative x. Okay? So let's just start off with x, y. Okay, so in this case, that would simply be the same equation, x squared plus y equals 9. Now inputting negative x, okay, just see, that would be x squared plus negative x squared plus y equals 9, which is equivalent to x squared plus y equals 9. So what's going on? xy is equivalent to negative x and y. So for every xy, there is negative xy. So that will make it what? It's symmetric with respect to, so I'm going to write that as WRT, with respect to the y-axis. Okay. Next, we can test it for y and negative y. Now clearly, putting x or negative x has the same value of y, so you don't end up with a negative value of y, so it's only symmetric with respect to the y-axis. Okay? Testing for symmetry. Always look for inputting x and negative x, or looking for y and the negative y. Okay? So, the third example. Write the slope-intercept form of a line with slope negative 2 containing the point 3, negative 4. Okay? So again, slope-intercept form was given by what? Y minus. Oh, actually, that was the point slope equation. Now, slope-intercept form was given by y equals mx plus b. Okay. Now, if you guys remember, this is the slope. But now the question is, how do we find the y-intercept? Okay. So let me start off with what we know. Okay. So y equals negative 2x plus b. Okay. Now, the important thing is, if we know one of the points, we can actually input the x and y value and find the value of the y-intercept. Okay, so let's try putting in 3 and negative 4. So negative 4 equals negative 2 times 3 plus b. Okay, so that's negative 4 equals negative 6 plus b. So b is what? b is equal to 2. So our final answer becomes y equals negative 2x plus 2. So that's our final answer. Again, remember, you can always input the slope because you know what slope is in front of the x. Finding the y-intercept, you can always input 3 and negative 4 and look for the y-intercept. Algebraically, you can end up with the slope-intercept form of the final answer. Okay. Now, our last example of the day is a circle question. It says, find the center and the radius of the circle x squared plus y squared plus 4x minus 2y minus 4 equals 0. Okay? Now this seems a little tough because we're given a general form and we have no idea what the radius or the center is. Okay, so let's start by putting all the x's together and the y's together. Now what do I mean by that is, if I have any terms with x in it, I move it on together. X squared plus 4x Now for the y squared, I put y squared minus 2y together. Let me just put minus 4 here equals 0, okay? Now guys, remember, what was the form of a standard form of a circle was that it was in terms of x minus k, x minus h squared plus y minus k squared equals r squared, okay? Now important thing about this equation is that these two parts are both squares, okay? So what we need to do to look for the center is that we apply something called completing the square, okay? Remember that. It says, this is called completing the square technique, okay? So in this case, since we know that the x's are x squared plus 4x, okay? Now, I hope you guys know your algebra well, okay? So x squared plus 4x comes from what? If you look at the original polynomial form, this comes from x something minus h squared. So, in fact, if I just simply write this out, x squared minus 2h x plus h squared. Okay? So what does this tell us? That is that this is in fact minus 2h. So if this is minus 2h, that will give us that h value we're looking for is what? It's actually in fact negative 2. Okay? So once we know that, we can write plus 4 here to complete the square. Okay? Now, important thing about this completing the square technique is that we not only write plus 4, we need to keep the original equation the same value. Now, keeping it the same value means that if I added plus 4 here, I should take it out again by saying minus 4. Okay? So I can actually now put this in a bracket and separate it. Okay? Let me continue with completing the square for y. So the second one, y squared minus 2y. Okay? Again, if it's squared, let me show you, y minus k squared would be what? Be the same as y squared minus 2ky plus k squared. So, looking at this equation, y squared minus 2y, we can know that k is equal to what? K equals 1. So, if k equals 1, then we can rewrite this as, again, put a bracket, y squared minus 2y plus 1. Again, we have to counter this out. So if you add plus 1 here, we should take it out. Outside here, minus 1. Okay? So, again, including the negative 4 at the end, we end up with the same equation. It's the same thing. Why? Because we just added 4 and took it out, added 1 and took it out, so it's the same thing. Okay? It maintains the same value. Okay? We didn't change the equation at all. We just made it in terms of squared forms. Okay? So, now that we know this, we can rewrite this out. So, x squared plus 4x plus 4 is the square of x plus 2 squared. Okay? The y squared minus 2y plus 1 is what? Is y minus 1 squared. Okay? And lastly, now we put all the values together. Negative 4, negative 1, negative 4 is equal to negative 9 equals 0. So if I move the 9 on the other side, okay, that will be equivalent to 9. Okay, so what's the center and the radius? Okay, the center is what? Negative 2 and 1. That's the center. And the radius is the square root on the right side because why? This is r squared. So the radius is equal to 3. Okay, so the center is at negative 2, 1. And the radius is 3. Now how do we look for this? We do a technique called completing the square. Okay? First we make it in the form of a square by looking at the term with the linear x. Same thing with the y. We look at the second term of the y. And we look at the constant here to find the value at the end here. We add it, take it out again to balance the equation. And finally, we put everything on the right side of the constant. And then we can look for the radius and the center. Okay? So that's it for the last question of today. Okay, so this is the end of the lesson today, and this was Ray Chung from A1 Prep. Thank you.